lag and seeing me with lag, or is it just me?
I think the audio is okay, the video maybe not, I don't know.
Okay. Maybe I close my video. You can see and hear me fine. Okay.
Fine. Yeah.
Okay. And I'm in sync because for me it's showing off sync. Okay. That's fine. So I see people are just joining. Welcome to everyone who's just getting comfortable, who's just joining us. Feel free. Okay, a little bit of a delay. We can deal with that. Feel free as usual to just introduce yourselves in the chat below, maybe who you are, where you're joining us from, and what your background is. And if you'd like, you can also share some takeaways you hope to get from today's discussion. And as usual, we leave about 15 minutes to 20 minutes at the end for Q&A. So if you have questions that you'd like answered, you can drop them in the chat, or you can leave them to the end of the discussion, and we will get to them then. So I give it another minute. I see people are still joining, and then we'll start.
Sterny, I think we can kick off. I think we lost her, so we'll wait another minute.
Let's see. It might be the dial-up modem that Sterny had. We'll see. Yeah, I think she might have lost the connection. So maybe until she comes in, we'll start with some introductions. What do you think, Daniel? Works?
Sure, yeah.
Okay. So you know what? Maybe Daniel, you want to start and introduce yourself?
No, I think you're on mute.
Oh, I can hear Daniel. It sounds like you too, right?
I think yeah, I can hear you, and I think you can hear me. So
okay. Let me just make sure that everyone can hear us. Let's see.
Yeah, now we can hear.
Okay. So Daniel, go ahead and introduce yourself.
So hello everyone. I am Daniel Wynne, the CEO of Mitri Security. So we are a startup based in France that was founded a year ago, and we are developing open source tools for data scientists to leverage confidential computing in order to handle sensitive data. And for instance, now we cover several aspects of the pipeline, from the training of AI models to the deployment, and we have initial use cases in biometrics, healthcare, and advertising.
Very nice. And it's good to be with you, Daniel. I'll introduce myself. My name is Noam Dror. I'm the Senior Vice President of Solution Engineering at Hub Security. Hub Security is a technology company that produces a confidential computing platform. And I've been in the cybersecurity space for almost 3 decades, working with large customers, understanding their challenges, their needs, and finding solutions for what they need. I've been also certified with certified CISO certification, CISSP. So I'm happy to be here and have this chat. Maybe a little bit about what we're going to do tonight. We are going to talk about confidential computing in general. We're going to cover a few topics. We're going to go through the market and the technology. We're going to go over a few topics like why we need confidential compute, what is confidential compute, and a little bit of how confidential compute works. So I think that would be a good discussion. Looking forward to have that chat with you. So maybe until Shterni comes back in, let's see if I'm missing something from what she wanted to say. We're going to have 15 minutes of Q&A at the end of this conversation. So please put your questions at the chat box down below. And I think we are ready to go through some questions. So maybe Daniel will ask you the first question.
I'm back.
Oh, Shterni, you're back.
Yeah, sorry, I don't know.
Okay.
Technology, I don't know what happened.
So take over as the host, please.
Okay, and if I for some reason, yeah, just you lose me again, continue and I will join. I'm really sorry about that.
We did a quick intro. We did a quick intro of Daniel and myself.
Okay, super. Yeah, but thank you everyone for joining us. Like Noam must have said, we're here today to discuss confidential computing. Noam is our very own SVP of Solution Engineering, and he's joined today by CEO at Mithril Security, Daniel Nguyen. So thank you both so much for being here today and joining us for this discussion. As usual, we'll leave about 15 minutes at the end for Q&A. So if you have questions throughout, you can drop them in the chat, or you can leave them for the Q&A box also, and we'll get to them at the end of our session. And Noam, did you want to say a few words to introduce the topic, or did we already cover that?
I think we covered kind of what we're going to go over tonight. And let's start the conversations. We have some interesting questions.
Yeah, okay, great. So let's just jump into it. Maybe because some of us are new to this topic, some of us are dealing with this topic in our day-to-day. Maybe Daniel can start us off by giving us just an overview of what confidential computing exactly what it is, and what kind of problems it aims to solve.
Okay, great. Thanks. So I think there is a definition by the Confidential Computing Consortium that defines confidential computing as the use of hardware-based solutions that are called trusted execution environments that are specific, let's say, black boxes that will be in charge of handling sensitive data. So the idea is that today, while we are resorting more and more to external solutions to analyze our data, it also means that we need to send data to people who don't necessarily trust, which can pose, some security and privacy issues. And for instance, if you use, I don't know, an AI to analyze your, let's say, medical data, then that means that your data goes to them and therefore is exposed to both, let's say, the startup that operates this AI algorithm, but also to the cloud provider. And this can pose issue, for instance, for security, privacy, sovereignty, and so on, because you no longer have control over your data when it's in once outside your perimeter. And this can be quite problematic for cloud adoption, for AI adoption, because data is at the core of AI. And therefore, those kind of solutions where we have this kind of secure environments to protect the data help make it possible that other parties handle your data without them having access to it, because those environments benefit from hardware or isolation or encryption of memory, so that even if I manipulate someone's data, I do not necessarily have the ability to see it, because what happens is, for instance, if you send data to me, for me to handle it, to apply my AI algorithm, so that is that you will encrypt it on your side. We will set up let's say, a secure connection between you and the enclave, so that I don't see what happens. The idea is that it's decrypted inside, and while it is inside, I cannot look at it, either through memory encryption or isolation. But that means that while it's being manipulated, I cannot see it. I give you a result. For instance, you are perfectly healthy. I re-encrypt the result and I send it back to you. And in that process, it is end-to-end protected. So that this way, I can technically provide you a service that benefits you. I can sell it to you, so I can make money. But also, I can provide you some level of guarantee that I was not able to see your data. Therefore, I cannot expose it. If I am compromised, I cannot leak your data, and so on. So this is a quick example, but those kind of technologies can really answer very long problems that have been around for a long time, which is like, how can I trust someone else with confidential data? And I guess it's a good solution to those issues. That's why we are in this field.
I would even maybe add, trust is really an important key of confidential compute, but I think it also made for securing the data, because up until we had confidential compute, you can protect data at rest, right? You can encrypt data at rest. You can use some access controls to protect it. And same thing goes for data on the move, right? So when data moves from one place to another, you can encrypt it. There are standard protocols today like TLS, and you can also use access control mechanisms like firewalls and ACLs to make sure only the right people have access to that data on the move. The challenge was, what do I do when data comes to the application and it's data in use? So for data in use, there was a challenge that you cannot just encrypt it because the application would not understand it. And you cannot really do a lot of access control on it because applications, privileged users still need access to that data. And that's how confidential compute started, to make sure that the three states of data, confidential data at rest, data on the move, and data in use. So now data in use is protected as well. As you said, you also already mentioned the TEE, the Trusted Execution Environment solution, but the high level of it is really isolation. The way we're going to work with it is we're going to protect the data, we're going to isolate the data, and once it's isolated, only the approved, authorized application can touch the data. That's the high level of it. Now, how it works, yes, we need to encrypt the data, we need the hardware CPUs to decrypt it, so there's a lot of how it's being done. But the high level is really, I want to make sure the data in use is protected through isolation. That's the high level goal of the solution. Trust is a really important key there, because that's the only way I can trust the data. And now we even see more and more issues of privacy. I want to make sure that the data is private, that even if it's not my data, it's someone else's data, I can protect their privacy. So we see that as another kind of emerging need for confidential computing. That's kind of the high level of it.
Thank you, Noam, and thank you, Daniel. Maybe you guys can give us a few more, and you touched already, Daniel touched on healthcare. You guys can give us a few more use cases, verticals, or market verticals, which are that can really benefit from the use of confidential computing technology.
Yeah, I can start with that. Well, healthcare is obviously, a natural industry for this kind of technologies, but you can also see it, for instance, in biometrics. We see some interest from clients around facial recognition, for instance, which is quite regulated in Europe. You can also see it in finance, for instance, for fraud detection, where, for instance, several banks might have to pull data to contribute to a fraud detection mechanism. There is also some use cases around the sharing of IoT data. I think someone in the chat mentions that. And maybe Noam, if you can help me with other things.
Yeah, sure. So I think just in high level, what we see in the market right now is that anyone who has data that is either highly regulated and or has very high value, that's where confidential computing is needed. So we mentioned healthcare. The reason that healthcare is so big on confidential compute is that the data is very valuable. So you can see, DNA of people, or medical information, or that is important sensitive for the user, but it's also highly regulated. Different regulations across the world, HIPAA in the United States, right? Everywhere there's regulation for that. So definitely healthcare is a big one. Finance, high value, very high value, but also highly regulated. Sometimes it's guidelines like FFIEC and things like that requires them to protect the data in a very strong way. And sometimes it's just that there's so much innovative in that space that they want to protect in the latest and greatest technologies in security there. And as Daniel said, we definitely see that in IoT and at the edge. And the reason for that is that there is a lot of valuable intellectual property information within the edge. So it can either be IoT that tells you how smart manufacturing is working. It can be an AI module that has access to a blueprint of a product, and that's the intellectual property of that plant or of that company. And it will tell the IoT how to work according to that blueprint. And we can now even see it definitely with the emergence of 5G network. We can see that a lot of cameras or any kind of other sensitive sensors that are using 5G networks and have private information about people, or the cameras are in sensitive places, they are definitely looking at those kind of confidential computing. And maybe last but not least, critical infrastructure is a big thing, right? So, we see a lot of nation state attacks, and nation states, the biggest target would be critical infrastructure. What would be better than, destroying the power grid or the energy grid or the telco grid, the communication grid. So anything that is a national critical infrastructure is definitely a big target for those nation states, and they'll do a lot. And because confidential compute is so new and very effective in protecting those applications, that's another place where we see deployments.
Mm-hmm. So I guess my next question is, why now? Why is it emerging at this moment, and why is this moment key for acceleration and adoption of the technology?
I think it's a combination of several factors. The hardware got better first. Now you can find massive hardware providers such as Intel, AMD, and soon NVIDIA that provide their processors with that trusted execution environment ability, which was not necessarily the case in the past. And for instance, NVIDIA, it's not out there yet officially. I guess it will be at the end of the year or beginning of next year. So Hopper will have the ability to, the Hopper GPU will have the ability to, train or deploy our models on confidential data. So that's a huge step forward. There's also the software stack, because sometimes you need to deeply rethink the way you design applications. For instance, that's the case for Intel SGX. They needed more tools to be developed for developers to be able to leverage that technology. And I guess it's also outside of this, there's the rise of cloud, for instance, and cloud is one major reason to adopt confidential computing, because it's good to leverage public cloud, but that means that you need to trust someone else. And finally, there is also, I guess, regulation that is being always more demanding, whether it is in Europe or in the rest of the world. So I guess the combination of all those factors, be it the ecosystem in terms of technology, hardware and software, but also regulation. Also, people become more and more mature in the way they handle data. They realize that to make value out of it, sometimes they have to share it. So I guess it's all those factors that make confidential computing interesting today.
Yeah, I agree. I think the biggest factor is that the technology is becoming more mature and easier to use, right? So if you look at what happened before, when SGX was first introduced to the market, you had to recompile your applications. There wasn't any tools to help you with that. So it was very limited in what it could do. Today, you just, if you do the cloud, you just do a checkbox and you have a confidential compute platform. There's not a lot to do it and configure in order to do it. So I think that's the biggest factor. The second factor, I think, is the way the industry works right now. People understand that we spend more money on security, yet every year there are more breaches. So, we're doing something wrong. You put more and more controls, more and more security spending, but breaches are going up in numbers. And I think because this is a different technology, it's a new type of control, I think more security people are looking at it as an option to maybe change that course, right? Where, we'll have less breaches than we used to have. So I think the combination of those two is the main reason for the growth in confidential computing.
Thank you. I'm sorry if I'm yawning. It's not that confidential computing is boring or disinteresting. It's about almost 8 p.m. here in Germany, so different time zones. I apologize. My next question would be then, why do you think that confidential computing is not very often heard of? It's quite a new topic for some people, even though it's been emerging for some years. What are your thoughts on the reasons for this?
To me, it's that it's very hard to, as we said, incorporate. For instance, if we talk about IntelliGX, I guess it takes a lot of expertise to start building stuff out of it. So there is a technical barrier to entry, but also there is a lot of education that needs to be done from the software engineers, security engineers, all the way to management, because this kind of technology does provide a real business value, as I mentioned, because we can unlock access to data that can truly change one way to do business. But then that needs to convince other people, from the engineers to the management, and it's quite kind of complex, because then you need to link this very technical solution to actual industrial use cases. And I guess in general it takes time, but if the technology is so cutting edge, it's even harder. So I think it's a little bit of that has made it hard. Maybe I'm wrong. I don't know. We don't talk it as much as, I don't know, blockchain or stuff like that, even though I guess it answers better the promises of blockchains, but it's not as famous. So I don't know, maybe we don't have good marketers as well. I don't know. That's an industry issue. But I guess that kind of event is also here to help promote that.
Yeah, and maybe because it's just a little bit new. It's new, and everything new takes time to get into the market, and as more and more players will get into that space, people will hear about it.
And we already have some questions here in the chat regarding cloud storage. And my next question would be for you guys: what are the challenges of confidential computing, and what are the challenges when it comes to confidential computing in the cloud versus on-premise?
Versus on-premise, yeah. So I think, first in the cloud, you have this thing called the cloud vendor, right? You have AWS and Azure and Google, and suddenly they have access to your infrastructure, right? Because what is the cloud? Cloud are servers and services running at a data center, and someone has access to it. So how do you trust them to put your data in their data centers and their systems? And I think confidential computing is really good in that space, because you're actually saying not only that your data is encrypted at rest and it moves and on the move, but also it's encrypted while in use. So it reduces the chance of the cloud vendor getting access to your data. So I think that's a big plus for the cloud. And of course, because it's in the cloud, it usually you have a lot of tools. It's easy to scale. So there's a lot of benefit for that. Each cloud vendor today is doing confidential compute a little bit differently, right? Azure is using the SGX platform. Google is using the AMD platform, and AWS is using Nitro, which is not even a CPU based. It is hardware based, but it's not CPU based. So it's all those. So the big three are using it very differently, and I think that's why there are different tools outside to do multi-cloud approach. Maybe that's also what answer the previous question, why it's not heard of, because each one is doing it a little bit differently. So I'm guessing there's some confusion in the market. On the on-prem side, I think the challenge is in different ways. The first one is, how do I make sure that as I go into my data center or even further to the edge or the far edge, my data is secure at all times? Because if someone takes my server physically, right, which cannot happen in very, very unlikely to happen in the cloud, in a cloud data center. But if someone is physically taking my server, I want to make sure that my data is still protected. And if they can, sniff the data through the hardware, that's a problem. So I think that's why it's important, and it's important also to have everything locally secured, not just in confidential computing, just add more stuff there. Now, what we also see in the edge space is that more and more people want to leverage those 5G networks, and they want to collaborate between different entities, different companies, leveraging the same edge sites, right? If I'm going to create hundreds of edge sites, it's a lot easier for 10, 100 companies to share 100 different edge sites versus one company to create their own 100 edge sites. So when you do that with on-prem solution, that becomes a little bit more difficult, and confidential compute can definitely help there as well.
Daniel, anything to add to that?
No, I guess good. I think there's one in the on-premise scenario. I guess also one of the issues is that you need the right hardware, which is, I guess, because it's hardware-based solution, not every machine can run it. So I guess that's also an issue. And while it's interesting to have it in the cloud, because you can find it more easily, especially when you use state-of-the-art hardware, you might not expect everyone to have it. It makes sense to go in the cloud, but because the technology itself protects you from the cloud provider, it's not that bad. I mean, things fit together, because imagine you want to use the latest GPU, then you might have to go to the cloud, but then you might have to trust the cloud, but because you don't need to trust the cloud with its solution, it's a closed loop.
So Daniel, it just popped my mind. You just made me now do a little bit of a commercial for my company. One of the things that we saw is really that problem, and therefore one of the solutions we have for confidential computing is just plugging in a card, which becomes a network card of that server, and you don't care about the x86 environment or the ARM environment of that server computing environment. So thanks for saying that.
No problem.
So is confidential computing here to replace all other security products?
Definitely no. Definitely no. So confidential compute, as we said, is doing one thing, which is protecting data in use and really protecting just the confidentiality of data in use. It's still susceptible to privilege abuse. If you're a root user, you can still break into a confidential computing platform and get the data. If I have access to the application, I can tell the application, give me the data. And it should give me the data because it thinks that I'm the right user to have that data. You still have the entire way to get into the confidential computing platform. You have the network layers, you have the hardware layers, and you have the operating system layers, and the hypervisors, and the containerization layers, and orchestration layers, and the application. So all those different controls still needs to be in place. In general, one of the basic things I learned in my CISSP, I don't know, 20 years ago was, you need to have your defense in depth. You need to protect all the different layers. You need to put controls for each one. And that's still the case today.
What can be done to accelerate adoption of confidential computing?
I guess the main driver, depends for whom, but I guess it's use cases, examples of, the technology, like use cases where we see what is the exact challenge, what current solutions do or fail to do, and what confidential computing can actually do to answer those challenges. And that, for instance, if we take whatever example is, for instance, in healthcare, in some cases you want to, for instance, cross data from different hospitals for a clinical trial, in a global fashion. But then how do you centralize the data to do this computation, without exposing one country's data to another? Then you need to find solutions to that. Confidential computing can be one, and therefore with that kind of technology, you can, be able to answer this issue of making, performing the statistics for clinical trials on multiple sites much faster and in a more secure manner. And so that's a great gain, for the pharmaceutical industries. So I guess that if we are able to provide more examples to the industry about what you can actually do with that, it would greatly help to accelerate it. At least that's my opinion. I think we need to be driven by the use cases, not just by the technology itself.
Right, I agree. We need to be use case driven, and therefore, I think to make it easier is to get the applications have kind of natural automatic plugin into confidential compute, right? When it started, as I said in the beginning, when it started with the original SGX, and you need to recompile your application and understand what's going to the trusted zone and what's not going to the trusted zone, that's very difficult to implement, and therefore, most likely will not be implemented. As we make it easier to deploy and kind of seamless to the user, and in order to do that, you need to have kind of an end-to-end solution. You need the applications to be part of it. You need the platform to be part of it. You need the hardware to be part of it. So as more and more players will get into that and make it very easy to deploy, it will be a lot easier to, to deploy the solution, and it would look seamless.
Mm-hmm. And one of the big challenges around data is regulation. So I'm wondering, how can confidential computing help solve some of these challenges that are related to questions of regulation?
Yeah, so I don't know. I don't think that it's in the regulation, GDPR law that says, oh, if you use confidential computing, go. I don't think that it's written somewhere, but I guess it would be good, because actually regulation often requires you to, prove that you have secured the data, prove that you're doing what you said you would do, or prove that, only a certain party would get the output of the computation, that kind of things. And actually, while most of those things had to be done with, contracts and so on, confidential computing can help you do all those things, but with a technical solution. as we mentioned, there is isolation, for instance, of sensitive workloads. There is a mechanism called attestation that can provide you proof that only a code you know and trust will be used on your data. So that answers a transparency of processing part of the regulation. And finally, there is you can put some complex key management system inside the trusted execution environment, so that only a specific recipient that is known in advance can get the results. So it might be hard for the regulators to understand that we actually answer technically their demands, but so I guess for now we can. It just reinforces your regulatory stance, but we hope in the future that it can actually unlock use cases that are not possible today. But this is very hard. For instance, in France, we have to go on a use case by case approach, where we go see the regulator and say, hey, actually that use case, do you think we can change the regulation where it is gray, because we actually outperform the state of the art, or answers your requirements, so that we can do it. Some people, not necessarily using confidential computing, but for instance, I've been able to get some kind of let's say approval by the French regulator to do what we call consentless advertising. So for instance, you don't require some consent in some specific use cases, and this has a real business value, because then you can do business much easier, and you can get access to data without all the constraints. But that only happens if you can convince the regulator that you protect the privacy of citizens. So complicated, but I think it's as I said before, it has real potential business value to provide that level of security, and especially, but the issue is really to prove it to the regulator. So it's too sad that there is not kind of systematic approach, a standardization to make it faster. But one by one, or maybe in the future collectively, we can try to make the industry move, the regulators move. And for instance, I guess we were both part of the Confidential Computing Consortium, where there have been efforts toward that goal. And so I guess we are going in the right direction.
Yeah. Yeah, I would say, you were talking about two things, Daniel. The first one is, how do we make sure we put controls to prove the auditors that we're doing what's needed to protect the application and data? And attestation is exactly that type of control. So we can attest that the workloads that are running inside the confidential compute are the one that we have known and we trust, and they haven't changed. So that's a very good way to prove to an auditor that we are doing our due diligence to protect data and applications, because we know that we tested those applications, and the same applications we tested are running in the production environment. So that's the one side. The second side is about the data. And I see a lot of changes in that space. One of the things that, as you said, we are both part of the Confidential Computing Consortium. And one of the things that happened lately is Confidential Computing Consortium answered an RFI by the US federal government to see how confidential compute can be a privacy security solution. So how do we secure private information leveraging confidential computing? Up until now, there are a few ways to protect private data. One of the ways is anonymization or de-identification. So you would take the data, you would change it a little bit. So once you change it, you cannot point to an individual within the record of information. So I would tokenize a user. Let's say Noam has a medical record. So I'll have an ID that will repeat itself for referential integrity, but then I would change my birth date, my address, any kind of things like that. So theoretically, no one can identify that it's me. I don't think that usually it doesn't work, because you can always refer to external databases. You can refer to what actually happened that you saw, like a visit or something like that. So it doesn't always work, but that's kind of the standard up until now. There's also a matter of synthetic data that is based on real data. So there are different ways that used to be up until now. Homomorphic encryption is another emerging way that is happening right now to protect data. And that means you never decrypt the data. In confidential computing, you do decrypt the data. The CPU decrypts the data in a secure, isolated environment. So you do have access to the actual data. In homomorphic encryption, you do not have access to the actual data. You just can apply different methods or functions on that data and get the results of that. So there are multiple ways to protect data. And I think one of the advantages of confidential computing is that you have full utilization of the data because you don't change it. So that's especially important for AI applications and for the accuracy of any kind of calculations of data, because you don't change the data, it's the actual real data. At the same time, because you don't run massive functions on encrypted data like homomorphic encryption does, because you have access to the actual data, it runs a lot faster. So maybe it does, and then there's a question of real time versus offline or near real time. When you de-identify data, it's very hard to do in real time because you need to change a lot of data before you actually process it. With confidential compute, you don't need to change the data, and therefore you can process it pretty quickly. So I think there's a lot of benefits in protecting private data, leveraging confidential computing.
So thank you so much, Noam. So we have just a few more questions, and then I'd like to move on to some Q&A, and we have a very lively discussion taking place in our chat, and some other industry professionals who will probably have a lot to share and to say, and I would like to invite them to take part in the discussion. So maybe I will just ask some final questions. Daniel, maybe just tell us a bit about Mithril and what services they provide. I mean, what differentiates your products within the market, and which use cases are they relevant for? Maybe this gives us a good background or a starting point for a deeper conversation.
Okay, so at Mithril Security, we focus on providing tools that are open source for data scientists to leverage those technologies. I think the biggest focus of our company is to make tools that are accessible, on top of being secure and fast. But accessibility is the biggest point, because data scientists are not necessarily security experts, don't necessarily know how to properly set up such environments, but they can definitely benefit from this to train AI models, to do data analysis, statistics, or deploy those models. And so we have a few products, and you can actually look at our GitHub. Both of our products are open source, whether it is to train AI models on multiple parties' data. That project is called Bastion AI, and or to deploy it. And the other product is called Blind AI. And we pay specific attention to make it possible in 2 lines of code, for instance, to deploy an AI model inside, for instance, an IntelliJ processor to benefit from the security advantages, while making it easy to be run. And I saw, for instance, that some people in the chat wondered about the performances on the latest hardware, be it Intel, AMD, or NVIDIA, with confidential computing abilities. We saw slowdowns that range from 0%, I mean, negligible in some use cases, to like 20-30%. So it is, in the latest hardware, it is, I think, rather good. You may say, 30% is, not that great. But if you compare it to homomorphic encryption, which is, 10,000 times slower, I guess it's not that bad given the security and privacy benefits you have. So yeah, our goal is really to, facilitate the adoption of confidential computing in the data science community. That's why our solutions are, we don't do anything. We don't pretend to do any workload, because also if you try to do too many things at the same time, the security properties you can provide, cannot be as strong as if you focus on a very specific use case. But this way, it's very tailor-made for data scientist needs, and we try to optimize it for speed and security. And use cases we see so far are mostly around the exploration, how can I say, the collaboration on medical data, and a little bit in biometrics for facial recognition, and yeah, that's mostly it. I mean, those, AI and data science is a very large field because you can use AI to analyze medical documents, textual documents. You can use it to transcribe, like, therapy sessions, which should be protected, by patient-doctor privilege. And the idea is that we can potentially do that within a secure enclave. So those are the kind of scenarios we cover.
A question for both of you is, what do you see as the future of confidential computing? Do you see lying ahead?
I think, the future of confidential computing is that there will be no confidential computing because it will just be computing, right? I think, if you think about what happened with encryption in the past, there used to be a module called TPM to store secrets. And it was only in high-end devices, and today you have it in every phone and on every computer. And on my old computer, I have another laptop here, and it tells me I cannot update to Windows 11 because my old computer doesn't have a TPM, but any other computer have that. So I think the same thing would happen with confidential computing. It will become a standard. And everything will run with confidential compute, encrypted in memory. The encryption will be open only when the application needs it in its own enclave. Each application will be isolated. I think that will be the nature of confidential compute. And I think with attestation will be a common practice, right? So if we used to do like hashing and making sure that things are not changing, in the future, you'll have automatic monitoring of everything that runs, and any changes will be validated. You'll check signatures, and you'll have trusted repositories to check. So, this entire, supply chain vulnerabilities that are happening right now, this will be solved because you'll have all the way from the supplier, from your vendor, an attestation of how the application looks like and what was the process that that application was tested, and will go all the way through a production environment to make sure that the right application is running there with no vulnerabilities, running in an isolated environment in a secure enclave. So that would be, that will be for every application. So if today we're talking about crown jewels and protecting just the sensitive data and just the critical applications, tomorrow it will be every application, every data. I think that's the future of confidential compute, to have no confidential compute.
Thank you, Noam. So I would like to move on to some questions, and we have some questions in the chat, and I think I just scroll back up and see what came first, and yeah, we work our way down. Of course, I'm sure more will come up. So let's see how many we get through. And very broad level, first question we have here is, what is the best strategy to protect healthcare data stored in cloud? And probably Daniel can lead us off on this. And I don't know if there's necessarily one strategy or the best strategy. Probably it will depend on the use case. On the specific use case, but Daniel, take it away.
I guess it's, everything, outside of confidential computing plus confidential computing, I guess, because I mean, confidential computing is essentially for the computing part, but, for, encryption as usual, as I mentioned, for instance, I'm transit, at rest, authentication. It's not like confidential computing. Use confidential computing, don't use anything else. Just the cherry on top of the cake. So I guess, I don't know if, we need to go through, it's all the usual stuff that we know we need to use. But then confidential computing comes at the last part where, okay, maybe you've stored it, maybe you've used some end-to-end encryption mechanism to store it, to not have to trust the cloud provider with your keys. But if you actually want to do the computation in the cloud, then at that last moment, if you want to, provide the best strategy to protect your data in the cloud, then you should use confidential computing at the last mile to actually protect data during its whole life cycle, so that you can benefit from the cloud provider without having to expose your data to them. I don't know if it's clear, but maybe I can.
Yeah.
Yeah, that's the data in use. That's exactly, we're going back to the beginning of what is confidential compute. It's protecting data in use, but in order to protect data in healthcare or in any other vertical, you need to protect data at rest, data at move, and data in use. So data at rest, there are standard encryption methodologies. You can do total database encryption on your databases. You can encrypt the network with standards like TLS, and to encrypt the data in use, you use confidential computing. But it's not just about confidentiality, right? Security is about confidentiality, integrity, and availability. So we need to make sure that you have the right access controls in the place, that you have the right audits and controls, that you log everything, right? So it's a standard way to do it. I would refer anyone to NIST 800-53. That's the risk management framework. That's kind of the Bible of how to secure an information system.
Mm-hmm. Anyone at Hub working on zero knowledge proofs? Ezekiel says.
So that's around encryption. I would say we are looking at it. The idea of what we do as confidential computers is about isolation. So we don't have to do zero knowledge encryption, but we are certainly looking at that.
Okay. Hilal says they're interested to hear more about the misconceptions surrounding TEEs. There seems to be some confusion about the use cases and attack vectors. Could you speak to what TEEs are not, are NOT?
Daniel, you want to take that, or?
Good question. I mean,
You want to call a friend? Should we do a skip?
I can do a high level.
Yeah,
So trusted execution environment, TEE, is all about isolation. How do you isolate it? You create a secure enclave. When you're inside the secure enclave, you can decrypt the data. So the data is encrypted in memory. In order for the data to be processed, you move to a secure enclave. The secure enclave, because we know the application, we trust the application because of that attestation, we can then decrypt the data, let the application use the data, and then we encrypt it back. So that memory is encrypted, it's isolated, and therefore no one can touch it. So that's what it can do. What it cannot do, it cannot protect you from access control violations or privilege abuse, right? If I'm the root user, I can still do whatever I want to the application, to the operating system, to the hypervisor. I can still do that. It will not help you protect against vulnerabilities of your application. So if your application is using a database and is leveraging a web server, you still need to fix, and patch your components of your application. So it's not, as I said, I think one of the questions was, can it replace all other security solutions? The answer is definitely no. You still need all of your security controls in place. This is a brand new category of security solution, and it's not replacing anything else.
And moving on to the next question, if it's okay, Daniel, did you want to add something to this?
Yeah, I guess, if we need to think about the terms, I guess, it's data in use confidentiality, data data in use, I mean, integrity of code. Basically, I think, I mean, the added parts, because, like, if you configure your, secure enclave properly, it can also do, like, the integrity, it can verify the integrity of data and so on. But really, the very interesting part are integrity of code and confidentiality of data. You can, no, it's okay. It's okay. Let's go to this next one. I'm not going to talk about it.
Okay. Given the tech overhead on running secure enclaves, wouldn't it be impractical for transactional low-level operations? I'm guessing they're referring to confidential computing. Seems that confidential computing is fit to purpose, or is fit for the purpose, for the purpose of dedicated computations only. Mm-hmm.
I don't know what you mean by dedicated computations. Because, for instance, I mean, in our case, we focus on AI workloads, and as I mentioned, it's, I guess, within reasonable, slowdowns and margins. So I don't know, like, what dedicated computations means.
I think they mean the performance. I think one, performance, and two, what can you run on confidential compute? So I think today you can run any container or any VM as a confidential compute secure enclave. So I think, today, definitely if you're going to microservices architecture with your applications, and even if you have like a monolithic application running inside a VM, the entire VM can be in secure enclave. And of course, a container can be in a secure enclave. So I think it's getting a lot easier to do confidential compute for any type of application. And definitely if you use the cloud, you can just spin up as many containers as you want. So if you think about performance issues, just run another container, right? It might cost a little bit more, but you get the security. It's always, security is always a balance between, ease of use, cost, and risk, right? So it's always about how much risk are you willing to take and how much you're willing to pay in cost and ease of use. I think the ease of use is getting a lot easier. The cost is something that you might need to look at if you want the same type of performance with that kind of security.
We've heard a lot about the advantages of confidential computing, but what about its bad sides and exploits, etc.?
I think we mentioned that there's protection of data while it is inside those, secure enclave and so on. But then the question is, what code is inside? And, then as we mentioned, there's attestation mechanism, but that means that technically you need to audit the code. And the more code you put inside of this, the harder it becomes, and the attack surface is bigger. So then there's the issue of So confidential computing can protect data, but what if I put a backdoor in my secure enclave? You can detect it because, as I mentioned, you have a hash of the code that is inside, and if it doesn't match, then you know that someone didn't put the code they said they would use on your code. But what if, for instance, like what if in some lines that you audited, they were, smart enough to put a backdoor, or even simply, they missed something, or they put too much code and there was a vulnerability in their code. So I guess there is an issue of, of what you put inside the enclave, and there's this concept of trusted computing base, which is actually the code that is running inside the secure environments. But then the question is, what do you allow people to do? And for instance, if you allow people to run arbitrary functions inside a secure enclave, you can actually leak data. Because if imagine I have a launcher to launch Python scripts inside a TEE, a trusted execution environment. Okay, it's good for usability. But what if the people that put the Python script, put a malicious Python script that leaks information? So then, even if we can put a launcher inside the TEE that might be secure, but if we allow people to execute arbitrary code on users' data and get the output of it, they can leak information. So it's not perfect. And, like it's, we might say that it's magical, but it's actually not. And there are things that we need to consider. And there is a huge trade. I mean, there's a trade-off between, the ease of use and security when you use that kind of solutions. So it's not perfect. In my opinion, that's why we focus on, on very specific use cases, not allow arbitrary computations from users to avoid that kind of issues. So in my opinion, if you really want to, reinforce your security, you should focus on a specific use case so that you know exactly what your users will do, and you can put mitigations so that they don't, try to expose data. So there are some security considerations when you develop such kind of applications.
I would maybe expand on that. Once you protect secrets with other secrets, which are the keys, right? Where are the keys coming from? So, some of the keys are coming directly from an Intel CPU. Who created those keys? Who created the seed? How are they created? It's usually a black box. So when you go to a CPU that has TEE, you don't really control the seed or the key that is there, and you don't know, how it was created. Can it be hacked? Same thing around attestation. When you go to the attestation, in the Intel example, you need to go to an Intel service. What if that Intel service is being hacked? You're now relying on Intel, right? Similar problems are happening with the other cloud providers and definitely with on-prem implementations. So I think as the space gets more maturity, it will be standardized, and not only standardized, it will be open and transparent, so other vendors can do the same thing. So maybe one day, someone like Hub Security will be able to hold the seed to the SGX keys to encrypt the data. So now you don't need to trust Intel. You trust Intel to execute the encryption, but you trust another company to create a truly random seed that is protected in a stronger environment, in an HSM type of environment on the same hardware, for example. I think that's kind of how we're going to address those challenges in the future. But we have time. That we're not there yet.
Bessie is sharing. Hardware-based security modules are not invulnerable. For example, Intel SGX has been exploited, and building around them has challenges as well. They're interested to learn more about how you deal with this and explaining it maybe to a lay audience or to layman terms.
I guess, like everything, I mean, nothing is perfectly secure. I think that's one thing we've learned. And I think it's about, knowing exactly what's the vulnerability. Like, does that first patch your stuff? I guess that's the very first thing you should do. But overall, it's really case by case. And how can I say? Let's take offside. I mean, in our experience at Metro Security, like what we do is that our head of security, is always looking for that kind of vulnerabilities. You try to patch them as soon as possible. We need to, assess really quickly what is the scope. Does this attack apply to us? What have we put in place? And I guess it's a permanent effort. Of course, it's not invulnerable, but I guess whether it is a secure enclave or not, you still need to do your homework at all time. So I think it's not because we use a hardware-based solution, so that's like SGX or others, that we should feel invulnerable. So I guess it's always listening to the market and what is being done, patching things. Also there's a lot of stuff around thinking ahead of how you design your application, because when you take IntelliGX and so on, for instance, it's a lot about side channels, but also that means is your application side channel exposed, or can you mitigate that from the beginning from for instance the way you design applications? Do you for instance, in our case, when we do deep learning, for instance, a lot of operations are such a resistance, but some are not. And so from day one, we try to minimize the operations that are at risk. What is the amount of code you put inside? So I guess there is one part that is proactive, where we, how can I say, have to, by design, make our solution, resistant to potential vulnerability in the future. But then there is a part also where we simply we go with the flow and apply some patch. So I guess there is, a mixture of both, trying to anticipate the market, but also when there's a new vulnerability, you come and you patch it. So I guess that's a bit how we see it. I mean, I don't know if there's a miracle solution for this.
I think, I'll take your point. Nothing is perfect, but in security, nothing is perfect, right? So what usually happens, let's take something a little bit more mature, because, confidential computing is really a new thing, emerging thing. Firewalls are old. Antivirus is old. And even then, even firewalls and antiviruses are not perfect today, even though they are very mature technologies. So what do? You put two antiviruses. You put two firewalls. That's usually what happens. If you don't want to get a zero-day vulnerability on firewall number one, you put firewall number two behind it. And same thing with antivirus. So we have a few customers that are looking at Hub Security as a second layer of isolation on top of the classic confidential compute TEE model. So that's another way to avoid some of the vulnerabilities and the exploits that are inside an SGX. Use another layer of isolation.
We have one more, we kind of have two. We have one in the chat, one in the Q&A, but we have to wrap up. So I'm going to ask the final question in the Q&A. We covered a little bit of it, but let's see if we can give more in-depth response. Confidential computing converts the problem of secure computation to secure key management for keeping data protected before decryption key. The decryption key is shared with trusted code inside trusted environment. How do we ensure that the centralized key management service or Key Vault or the trusted authentication service that key management itself relies on does not become the backdoor to break through to break the confidential computing?
That's a very good question.
I guess
I will
you
send
said
it in the chat so you guys can see it as well if you didn't see it.
yeah, actually I didn't see it, but
Yeah.
There you go.
So
well, so I guess the key management system, I mean, is inside the TEE. So it can be attested, right? So I guess in the case, and for instance, in our case, like, the code is open source, so you can actually see how we manage the keys inside the enclave, how data is manipulated, and So I guess one way is to say, you open source those parts, or at least you have them audited, and you make the audit available to your clients. Because actually, one of the good points, I guess, of TEE is that you can see the code that is inside. So yeah, that key management, I guess, needs to be transparent, but you can actually verify how it is implemented. So I guess that's one way. I don't know if I'm saying if you agree with me, but I guess
I'll just say that the way we see it is that in our solution we have a separate execution environment, not on the Intel. It's a card, the PCIe card that is on that x86 environment that protects itself, right? It uses its own execution environment, its own processors, its own CPU, its own memory, and its own drive. And this is where we keep a fully functioning HSM to protect the keys that are separate from the x86 environment. And that's how we protect the keys without getting any of those vulnerabilities of the TEE environment. So decouple it, I think, is the way to do it. Today it's not as easy as it should, right? So I think as we mature confidential compute, it will be kind of a plug and play. to get an HSM. It is getting a lot easier, but get an HSM to manage the keys for all key management, key creation, and key fetch and store from a confidential computing platform.
Should we take one last question, because there is there's one more here, and then I think we need to wrap up. But Bobby is asking, what do you think of the shift from very narrow TEEs like Intel SGX to easier solutions like AMD SEV for the entire VM? What do you think of the trade-offs between the two?
I think that it makes it easier to develop. That's true. But then, I mean, for instance, in our case, we have been mostly working on Intel SGX so far. It's only recently that we are starting to do the shift towards AMD SEV. So regarding the new threat modeling and things like that, our team is working on that. It's you need to increase the computing base. So it makes things easier, but there are also some attacks you don't have anymore because now you trust the attack surface is different. But then that means you also need to have more code inside of it. So it's I guess it's not completely easy to say if it's I guess it depends on the scenario and how you design your application and so on. So I think in our case, I think we're maybe a bit early to provide a fully formed conclusion regarding that, but each has its pros and pros and cons. In our case, developing in Intel SGX was a bit complicated at first, but after you are used, for instance, we use like the Intel SGX, the Rust Intel SGX SDK, and once you start to know how it works, it was possible to design an application with that, and having a minimal code base in Intel SGX is not always. It is a pain, but it's also not a pain. It's a very complicated scenario because some attacks are present in one scenario, in one case, not another. But then you have less code to audit in Intel SGX, which is not that bad actually, because it's really you can keep it minimal. So I don't know if we have a definitive answer yet, but I guess we'll see. In any case, we're going to get an audit soon, so I guess we'll see how it works out at that time. But I think the most exciting thing with AMD SEV compared to Intel SGX is the ability for us to use secure GPUs. I guess Intel TDX it will be possible most likely in the future, but I guess for us it's really the main game changer with AMD SEV. But yeah, I think we'll see.
Yeah, I would just say, as you said, it's about the boundary of trust. I think there is place for both the technologies, right? AMD SEV is protecting a full VM. Intel is going that way too with TDX that will protect full VMs as well, but it doesn't mean that you should not secure just a piece of code, because that's an advantage as well. So I think we'll see both types of TEs out there to implement both. It's a lot easier to manage a whole VM in a secure enclave, but it might be more secure to encrypt only a piece of code that is the most sensitive to the application, because you reduce the attack surface. So I think both approaches are good, and I think both approaches will be used in the future.
Okay. And with that, I would like to thank both of you for a wonderful discussion. Thank you for joining us this evening, this morning, this day, wherever you are in the world. All of our participants who registered for today's event should be receiving an email in the coming days with contact info for both Noam and Daniel. So if you have any follow-up questions, anything itching your brain, you can shoot them a message and reach out to them directly. I'm sure they're happy to respond. and make that connection. Otherwise, you can follow us on Hub Security on LinkedIn, and we do some promo, LinkedIn, Twitter, and find out more about future events we're hosting. And yeah, we hope to see you there. If you have any other questions, feel free to write us. And I'd like to thank once more our speakers for today, Noam and Daniel, for joining us. And I hope to speak to you guys again soon. And I hope everyone is staying safe and healthy at home, and has a wonderful rest of their day, evening, or afternoon, wherever you find yourself.
Sounds good. Thanks a lot,
Right.
everyone.
Thanks for inviting me.
Thank you, guys.
And thanks for coming,
Bye.
guys. Bye.
Take care.